Good day, everyone. I am Andrei Perez, and together with me is Jutis. And today, we will about to use the principle of induction to establish the formula 1 times 2 plus 2 times 3 plus 3 times 4 plus ellipsis plus n times the quantity of n plus 1 is equal to n times the quantity of n plus 1 times the quantity of n plus 2 all over 3 for all n is greater than or equal to 1. Our first step is the basis. We will be going to verify for n is equal to 1. We have here n times the quantity of n plus 1 is equal to n times the quantity of n plus 1 times the quantity of n plus 2 all over 3. All we need to do is to substitute 1 to n, and we can have 1 times the quantity of 1 plus 1 is equal to 1 times the quantity of 1 plus 1 times the quantity of 1 plus 2 all over 3. We will add the values inside the parentheses. Then, we can have 1 times 2 is equal to 1 times 2 times 3 all over 3. And now, we have 2 is equal to 6 over 3. We will simply divide 6 into 3, and we can get 2 is equal to 2. Since the left-hand side equals the right-hand side, which is 2 is equal to 2, we have successfully verified that the formula holds true for n is equal to 1.
After verifying the base case, the next step is the induction hypothesis. In this step, we assume that the formula works for some arbitrary value n is equal to k. This means we believe the formula is true for k even though we haven't proven it yet. This assumption will serve as our foundation to prove that the formula also works for the next step, which is n is equal to k plus 1. If we succeed, this proves that the formula is valid not just for the base case but for every value after that. In simpler words, if one domino falls and we show that it always causes the next domino to fall, then eventually all dominoes will fall. That's the power of mathematical induction. Assume that 1 times 2 plus 2 times 3 plus 3 times 4 plus ellipses plus k times the quantity of k plus 1 is equal to k times the quantity of k plus 1 plus k plus 2 all over 3. And we need to prove that 1 times 2 plus 2 times 3 plus 3 times 4 plus ellipses plus k times the quantity of k plus 1 plus k plus 1 times the quantity of k plus 1 plus 1 is equal to k plus 1 times the quantity of k plus 1 plus 1 times the quantity of k plus 1 plus 2 all over 3. And to simplify the left hand side, we get k plus 1 times the quantity of k plus 2. And to simplify the right hand side, we get k plus 1 times the quantity of k plus 2 times the quantity of k plus 3 all over 3. Now, 1 times 2 plus 2 times 3 plus 3 times 4 plus ellipses plus k times the quantity of k plus 1 plus k plus 1 times the quantity of k plus 2 is equal to k times the quantity of k plus 1 times the quantity of k plus 2 plus all over 3 plus k times 1 times the quantity of k plus 2. We just simply add k plus 1 times the quantity of k plus 2 to the original formula. Next. Since in the right hand side, the two terms are dissimilar terms, so we cannot combine it directly. What we need to do is to get the LCD, and the LCD of these two terms is 3. Since the LCD is 3, we just simply copy the first term, and the second term, we just simply multiply the numerator by 3. So, since they already have the same denominator, we can simply combine them. So, we have k times to the quantity of k plus 1 times to the quantity of k plus 2 plus 3 times to the quantity of k plus 1 times to the quantity of k plus 2 all over 3. And as you can see, the two terms have the same factors, which are k plus 1 and k plus 2. So we need to factor it out. If we factor it out, the answer will be k plus 1 times the quantity of k plus 2 times the quantity of k plus 3 all over 3. This is exactly the formula with n is equal to k plus 1. So the step is proven. Hence, the formula holds true for n is equal to k plus 1, and therefore, by principle of induction, the formula is true for any positive integer n. And to summarize, we proved that the base case is true for n is equal to 1. We assumed it was true for n is equal to k. We showed it must then be true for n is equal to k plus 1. Therefore, by the principle of mathematical induction, the formula is valid for all natural numbers n. This example shows the power of induction. Instead of checking one number at a time, we use a logic to prove the formula works for every number. Thank you very much for watching. We hope you now have a clearer understanding of how the principle of induction works in proving formulas. Have a great day!